Find the domain, the roots, the vertical and horizontal asymptotes of the following rational function. Let's start with the domain. Now the domain of f of x, we always look at the denominator. Remember, d for denominator. And we set the denominator, 2x squared take away 4, as not equal to 0. And we solve for x. Let's add 4 to both sides of the equation. 2x squared not equal to 4. Let's divide both sides of the equation by 2. X squared not equal to 4 over 2. 4 divided by 2 is 2. Let's take the square root of both sides of the equation. X not equal to plus and minus square root of 2. Therefore, our x is plus square root of 2 and negative square root of 2. Our domain is equal to the set of all real numbers except for positive square root of 2 and negative square root of 2. If you need to write it in interval notation, it would be written as negative infinity, negative square root of 2, and negative square root of 2, positive square root of 2, and positive square root of 2, and positive infinity. That would be the domain in interval notation. Now that we found the domain, let's move on to the roots. The roots, or the zeros, is when the function is on the x-axis. And when we're looking at the roots, we look at the numerator. So 3x squared take away 27, and we set it as equal to 0, and we solve for x. Let's add 27 to both sides of the equation. 3x squared equals 27. Let's divide both sides of the equation by 3. X squared equals 27 over 3, which is 9. Let's take the square root of both sides of the equation. X will equal positive and negative the square root of 9, which is positive and negative 3. So our roots is x equals 3 and x equals negative 3. Now, we found the domain and the roots. Let's move on to finding the vertical and horizontal asymptotes. The vertical asymptotes is basically our domain. What does that mean? Here we mentioned that the domain is the set of all real numbers except for positive square root of 2 and negative square root of 2. That is the vertical asymptote. So our answer is the vertical asymptote are x equals square root of 2 and x equals negative square root of 2. These are the vertical asymptotes. And finally, the horizontal asymptote. What you need to be aware of for the horizontal asymptote is the degree of the numerator function and the denominator function. When the degree of the numerator is less than the degree of the denominator, that means we have a horizontal asymptote at 0. When the degree of the numerator is equal to the degree of the denominator, that means we have a horizontal asymptote at y equals an over bm. I'll tell you what that means in a second. When the degree of the numerator is greater than the degree of the denominator, that means we do not have a horizontal asymptote. And when the degree of the numerator is equal to the denominator plus 1, that means we have a slant asymptote. We have a slant asymptote. So, in order for us to find the horizontal asymptote in this case, we need to take a look at the degree of the numerator function and the denominator function. Now, the degree is associated with the exponent of the function. We need to take a look at the leading coefficient, which means the coefficient with the largest exponent, and compare the numerator and the denominator. Now, as we can tell here, the numerator and the denominator degrees are equal. We have 2 and 2. They are equal. Therefore, it belongs to this category over here, when n equals m. Okay, that means we have a horizontal asymptote at y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Right? In this case, the leading coefficient of the numerator is 3x squared, and the leading coefficient of the denominator is 2x squared. We just divide them by each other. So our horizontal asymptote is y equals 3x squared over 2x squared. Now we can simplify this fraction by dividing x squared by x squared, and that is canceled, right? We are left with 3 over 2. That is our horizontal asymptote. Here we have our rational function, and we need to find the domain. Now, as mentioned, the domain of f of x, d stands for the denominator. So we look at the denominator to find the domain. The denominator is 5x squared take away 25, and we set it as not equal to 0. So 5x squared take away 25 not equal to 0. And we solve for x. Let's add 25 to both sides of the equation. 5x squared not equal to 25. Let's divide both sides of the equation by 5. X squared not equal to 25 divided by 5, and that is 5. That is 5. Now, let's take the square root of both sides of the equation. The square root of x squared not equal to plus and minus square root of 5. Now the square root of a squared number cancel each other. So basically, they're canceled. X is not equal to plus and minus the square root of 5. We have our domain. The domain of f of x is the set of all real numbers except for the square root of 5 and negative square root of 5. That is the domain of f of x. If you need to write it in interval notation, that would be negative infinity, negative square root of 5, and negative square root of 5, positive square root of 5, and positive square root of 5, and positive infinity. That would be the domain in interval notation, in case you need it. Right, so we have found the domain. Let's move on to find the roots or the zeros. Now we know that when we're looking at the roots, we have to use the numerator for that. The numerator, x squared, take away x, take away 6, we set it as equal to 0 this time. And we solve for x. Now, hopefully you have noticed that this is a quadratic equation. It is in the form ax squared take away, not take away, plus bx plus c, where a is 1, b is negative 1, c is negative 6. We use the quadratic formula, negative b plus and minus square root of b squared, take away 4, multiplied by ac, divided by 2 multiplied by a. And now we just substitute our information. Our roots when we set the formula as a plus, x is 2, and when we set it as negative, x would be negative 3. Here are our roots. So the function touches the x-axis at x equals 2 and x equals negative 3. Let's move them over here to the side. Right, let's move on to the asymptotes. Right, now starting with the vertical asymptotes, as we mentioned before, that the vertical asymptotes are basically the domain of the function. So our vertical asymptotes are at x equals square root of 5 and x equals negative the square root of 5. And finally, our horizontal asymptote, we need to compare the degrees. Now clearly we have the leading coefficients being equal, so our horizontal asymptote is looking at the leading coefficient of the numerator and the leading coefficient of the denominator, x squared over 5x squared, right? Simplifying that fraction means our horizontal asymptote is at 1 over 5. Y equals 1 over 5.